The session now that we are going to begin is Decoding the Space Economy. All those who are inside the hall, if you would like to inform your colleagues or friends to join us as soon as possible so that we can begin with the proceedings. So ladies and gentlemen, good afternoon, welcome back. And we are now going to go ahead with the session on decoding the space economy. On the dais, we have our eminent panel. Our keynote and distinguished moderator, keynote speaker and distinguished moderator, Mr. Jose del Rosario, is the research director, NSR. And our eminent speakers for the session are Professor Vinay Dadhwal. He's from Indira Gandhi Chair, Professor for Environmental Sciences, National Institute of Advanced Sciences. And Professor Sunil Mani, Director and Professor, Reserve Bank of India, Chair, Center for Development Studies, CDS. Mr. Sreeram Ananthsayanam, he's partner Deloitte, Touche, Tohmatsu India LLP, and Mr. Saurabh Kapil, Associate Director, PwC Space Practice. And the topic for the session is Decoding the Space Economy. And the time duration is approximately 1 hour 15 minutes, which include the opening keynote presentation by a moderator, Mr. Jose, followed by deliberations, addresses, or presentations by all the eminent speakers. And if time permits, we'll have question and answers in the end after all the presentations are over. With those words, I hand over and invite our eminent keynote speaker for your opening remarks and the keynote address.
Thank you very much, and happy Diwali, everyone. I think I have a presentation. No, Jose del Rosario, NSR. I guess my presentation didn't make it. That's okay. Just a few opening words. Congratulations to the launch of OneWeb. 26 satellites, commercially deployed, very successful. India is at people's minds right now. And coming into the conference, we have clients. We're a consulting company. My colleagues, competitors, if you will, are also looking at India as the growth market, the next linchpin market as regulations get opened up. We heard from speakers this morning looking at the space sector, the satellite sector, as the growth strategy going forward in terms of technology innovation and benefits to mankind, to the local population. Very noble goals. So the thing with putting out numbers, GDP growth, share of space capability within the economy, it's very important to look at what should be in or what should be out. We had estimates. I'm going to use Ernst & Young because they're not here today, and my colleagues would put out their own numbers. But Ernst & Young put the Indian space economy at $9.6 billion, projected until the end of 2022. If we look at the budget of ISRO, I believe it's 1.7 billion. So if we take out ISRO's component in terms of budget from the 9.6 billion, the bulk of the Indian space economy rests with the other sectors. And I would assume this would be with the private sector. So at 9.6 billion or other numbers that are, I think, below Again, my colleagues will put out that number. Do we believe that the private sector accounts for the bulk of the space industry here in India? I'd like to use the audience for some feedback before we go to the panel. So do you believe that the private sector dominates the space industry of India today? Raise of hands, please. One. Good to assume that the rest don't believe that the commercial industry is the largest part of space India? Raise of hands, please. One. And the rest, two. And the rest are on the fence. So not clear. So hopefully our panel sheds some light on that. More statistics because we're part of the, we're a numbers company. So in terms of growth, again, and the importance of the space sector, connectivity, we've heard that continuously, bridging the digital divide here. My colleague who's from Bangalore said the population of India, rural versus urban, I think it's about 67% rural. And of that percentage, 30% are connected. And he said that, and I hope his numbers are right, over 500 million people are not connected to the internet. That's your digital divide. The only way to bridge that digital divide, technologically speaking, economically speaking, is through satellites, because you can leapfrog that capability. The problem, he says, is price, regulation, and openness of the market. Is that agreed as well from the audience? Price, regulation, and maybe a private sector? Yep, one. Okay. So I think before we get to the panel and some presentations, I think we're all on the same page. India presents perhaps the largest opportunity in Asia today and going forward. There are regulatory elements that have to be resolved. The private sector is coming in, and the pace of that opening the floodgates, so to speak. From conversations before the session and the conference, the locals, you, don't think it's fast enough. And the number that I'm hearing is that it should happen in 5 years. So again, last survey question, do you believe that the floodgates, regulations, a level playing field will take place in India within 5 years? Show of hands? Vast majority, excellent. So that's great news. Look forward to the panel and our discussion. So with that, I'd like to welcome Professor Sunil for his presentation. Thank you.
First of all, I wish to thank the organizers for giving us a chance to present this paper, which is a forthcoming journal article in the Elsevier Science Journal Space Policy. And we have used an eclectic framework for measuring the size of India's space economy. And this is actually a joint work with Professor Dadhwal, who is sitting here, and Dr. Shaju Man, who is sitting in the dais. The way we are going to do this is, I'm not going to go through my entire slides because it's quite a lot of things here. So what I would wish to present here is that why are we talking about the space economy in India? First is that it's a very rare example of a particular sector in India where a considerable amount of domestic technological capability has been accumulated over a very long period of time in designing, manufacturing, and launching satellites and satellite launch vehicles. Okay, and purely through indigenous effort. Of course, there has been some effort in licensing technologies from abroad, but by and large through indigenous effort. So we have very few such examples from the Indian technological scene where considerable amount of capability has been built through indigenous efforts at all. And second, it's been done by a public sector organization, which of course is ISRO. And third, it is the state has collaborated with the private sector. So the question was asked, what is the large size, is it the public or the private sector which is the most important sector? And we would argue that what we talk about the space economy, we need to have a proper understanding of what we mean by that. And when we actually demystify the space economy, a large proportion of what we call the space economy is actually by the private sector. Although the inputs to that is from the public sector, because you have to make a distinction between inputs and outputs. For instance, space budgets cannot be included as part of the space economy for the simple reason that that is actually creating the economy around it. So we are talking about a satellite account in the national account sense of the term. Okay. Fourth, this is also a very good instance of what we refer to as a frugal innovation, because exactly the same technology can be developed and maintained at a fraction of the cost of what it would cost in other countries in the world. And in fact, you can give very many examples from the ISRO's case itself, how this has been done. So for all these reasons, I think it is very important to have an understanding of what exactly is the space economy, because in India, we do not have any satellite accounts as part of our national account statistics to understand various kinds of economies. So we tend to use terms like digital economy, the blue economy, the white economy, etc., and so on, without having a clear idea as to how the size of those particular sectors are actually measured. So what we are going to do is to look at various frameworks which are available internationally speaking. The first framework that's available is the OECD framework. And in fact, our argument is that the OECD framework, while it is very interesting to, to dissect and decompose the contours of the space economy, doesn't really allow us to have an idea about the actual size of the space economy, because the size should be expressed as a percentage of the GDP so that you can easily understand it. Because if I'm just going to give you the size in terms of an absolute number, you will not be able to interpret how big or small that sector is. Now, of course, you have the UK Space Agency, which has actually has a much more meaningful decomposition of the space sector. And in fact, what we have done is we have tried to mix the OECD and the UK Space Agency framework. And then, of course, very recently, the US Bureau of Economic Analysis for the first time has come out with a size of the US space economy. This has been published also in the same journal where our article is going to be published. And they have arrived at the, using very detailed input-output tables, they have been able to sort of measure the space economy in each of the three broad sectors of the of an economy. For instance, in the agriculture, in the secondary sector, which is basically manufacturing, and also in the services economy. Okay, so now what exactly is the OECD framework? Just to give you a very quick idea, the OECD framework has basically divided three broad ways. First, it looks at the inputs of the space economy. Then it looks at the activities and outputs of the space economy. And third, it talks about the impact of the space economy also. Okay. Now, that's one of the reasons as to why there is a great overestimation of the size of the space economy, because when you are going to include also the impact, the size becomes very large, because you have to bring in both the direct impact as well as the indirect impacts, and most of the indirect impacts are simply guesstimates, and as a result you have a very large size. First, the inputs which they take into account is share of the budget for space activities in a country's GDP, and second is the assets of the space sector, and third is the human capital which is employed in the space sector. Okay, and output, of course, is in terms of the space manufacturing industry, the satellite telecom industry, to which the chairman referred to also, and the satellite earth observation or remote sensing, and then of course the insurance market, which is the premiums which are paid and claimed, and then of course the international trade in space products, which is exports and imports of space products, and lastly the innovative activity, which is measured in terms of the number of patents granted, the number of articles published, scientific articles published in the area of space science, etc., and so on. Now, some quick comments on the OECD framework. While this framework is looks very attractive because it looks into both inputs and outputs, etc., and it also helps us to delineate the contours of the space economy. It will not result in a summary measure. As I said, if we want to express the space economy, you need to get a summary measure put that on the numerator, and then on the denominator you have the GDP, so that you can talk in terms of a percentage share of the economy, etc., and so on. And this we are not be able to do it because the input and output measures that we talked about is a motley assortment of both physical and value-based measures. For instance, the number of the human resource engaged in is basically a physical number, and whereas the space budget is basically a value number. Now, how can you add up all these things and then express that as a percentage of the GDP? Now, hence, we have, if you look at the world space economy, you have these different estimates which are available. You have estimates ranging from 320 to almost like to $155 billion. Now, I understand currently it is estimated to be about $467 billion. Now, I think the IDA, Science and Technology Policy Institute in Washington, which is a think tank, has actually looked at these methodologies very carefully and showed that there is considerable amount of overestimation and double counting. And as a result, if you remove or net out all those instances of double counting, the size of the space economy simply collapses to about 155, had gone up to about $166 billion. So I think this has to be borne in mind when you are talking about the size of the space economy. Now, some critical comments on the OECD framework, and you have the first is that the OECD framework, I'm sorry, I will not go into these details now. I'll go into the UK Space Agency framework. This is very useful because it divides the whole economy into four parts, four subsectors. First is space manufacturing, which itself has a number of subsectors there. And now you can identify most of these sectors. You can get the value added or value of output of each of these sectors. Then you have space operations, and then you have space applications, and then of course you have ancillary services. Now it's possible for you to get the revenues or output or value added of each of these subsectors, and then add them up, and then express them as a percentage of the GDP. And this is precisely what we have done. Now, the US Bureau of Economic Analysis is the most scientific way in which it has been done, but it has been only done for, it's a one-off study, and they are very clear that they will not do the study unless more funding is available. But they had a major advantage because in the US they have detailed supply and use tables for arriving at the national accounts characteristics of the space economy, and such as gross output, value added, and employment, and compensation or wages. So all these things are available. So theirs is the most systematic and scientific study among all the other studies. So in terms of the UK Space Agency, what are the major advantages? Because this is what we have actually used. Okay. First, it differentiates between stock and flow variables because assets are in the form of stock. Okay. So if you sort of add them up, then it will be a very large figure, and that's one of the reasons as to why the overestimation again comes, apart from the fact of including both inputs and outputs together. So here it differentiates between stock and flow variables. All the components are flow variables which are available on a yearly basis, so it can be computed annually. Okay. Second, it spells out the subcomponents of all the four segments. So, for instance, when you talk about space manufacturing, it spells out each of the subsectors of space manufacturing. And when it talks about space applications, it spells out the subsectors of each of those. Okay. So, consequent, the possibility of double counting, which is rampant in all the other frameworks, as we have seen from the the earlier estimates, that it ranges from about 160 billion to almost like 360 billion dollars. It is that is virtually absent or minimal. This helps us to get a much more realistic picture. Okay. Now, I will not go into the engagement with the literature, etc., and so on, because I think that's not really required. So I will finally come to measuring the size of India's space economy. So according to us, based on this UK's space agency framework, what we have done is we have got the size in terms of, let me just, in terms of rupees crores, and we have adjusted that for possible double counting because of the inclusion of government ISRO's budget in some of these estimates. So you have both adjusted and unadjusted size, and this is expressed as a percentage of GDP. So according to us, it is for the period, we have done this estimates year-wise, 2011-12 until 2020-21, and if we have the numbers for the subsequent years, it's possible for someone to replicate these estimates. And so this is something like 0.2% of the GDP, the size of India's space economy. So in terms of absolute numbers in billions of dollars, we are talking in terms of about $6.1 billion. Now, our argument is that this size is expected to come down, not increase in the future, because government's budget, which is basically the main input to the space economy, has been going down. For instance, there has been a systematic decline in the ISRO's budget for 2020-21, and in fact, it is that budget, which is the investment, which is the input, which is actually driving the size of the space economy. So that's expected to go down, unless, of course, the private sector is coming in a big way and overcoming that. And we have not seen, we do not have any estimates of the private sector's involvement in a very clear way, especially in areas like space manufacturing, etc., and so on. Okay. And how does our estimates compare with the other estimates which are available? There are only two other estimates which are available. One which is done by the PwC, which actually was published in 2020, and that gives a figure of about 7 billion. So our figures are pretty close to PwC. The only difference is that PwC doesn't make in that report how those 7 billion was arrived at. There is no, it is just a summary figure that's given, and it's the methodology is not explained at all in the study. And the second one is, of course, the most recent one, which was just published earlier this month by EY, and that gives a figure about $9.7 billion. But that basically is refers to year 2020. So we have our estimates, which are about $6.1 billion, PwC, which is about 7, and the EY, which is about 9.7. So roughly, they are all in the same sort of range. Now, again, I must say that the EY also doesn't make it methodology clear, although it does give some, some subsectors, because they use an upstream and downstream sort of sectors to arrive at the total size of the space economy. Okay. Now, how do we compare with the US? US is about $194 billion according to the Bureau of Economic Analysis, and this is, of course, a very good figure. So from ratio of India to the US is about 0.28 for the latest year for which the data are available. The latest year, of course, is 2019. Okay, so and that's quite understandable, because the US has a much longer history of investments and activities in the space economy. Now, of course, the different components are given here, and I could first of all go into some of these during discussions, etc. So basically, the point that we are trying to make is that I think we need to have detailed value-added figures for each of the subsectors of the space economy to arrive at a correct picture, because that's the way national account statisticians would compute the size of the economy. Okay, so the same thing should be used. We have actually used only the total revenue, so there is a certain amount of overestimation even in our figures. So, so I think $6 to $7 billion would be, I think, a good figure, but it's the expectation that this is going to increase in the future is very much dependent on the public sector budgets for space research, which, as I've mentioned before, has been going down over the years. Okay, so if the state is withdrawing itself from the space activities, and I'm not sure whether the private sector is actually moving into to overcome the deficits created by the withdrawal of the state sector. So I think it very much depends on further investments by the state into space activities for the space economy to generate much more private sector activity, because we have done some multiplier computations also, and the details are there in our paper. I'm not going to the details of that for want of time. So I think I can come back and clarify doubts if that's required. Thank you.
Thank you very much, Professor Sunil. Professor Vinay, your presentation, please.
Good afternoon. Thank you, Professor Sunil, for summarizing our work. So there was not much left for me to add, but I just thought, since we are collaborating and we come from different vantage point, and I spent about 38 years in ISRO doing Earth observation, I will try to look at the Earth observation and various dimensions of its use, economy, impact, and intangible also. But before we start, let me point out, all countries started their space program not looking at economy. For some, it was offshoot of the military complex. And for India, the idea was to leapfrog from very poor and undeveloped state, and leapfrog with three things in mind. One was very poor communication. The second was education. Third was monsoon prediction for farmers. Basically, it was agriculture. And so you just, those of you who are familiar with the history of ISRO, so 1975 and 77, two very landmark experiment on educating the villages through satellite, the SITE and STEP, which are the largest mass communication experiment were done. And all of these experiments were done with social impact, okay? But we will not go there. We will start with the work of Professor U. Shankar from Madras School of Economics, who till now has done the most comprehensive study on the economic impact of the India space program. And I'm just taking the EO part, not necessarily the launch vehicle and other part. What it says is between 2000, of course, ISRO was set up in 69 and 72 as DOS, but the Earth observation program really started from early 80s. From that time to 2005, the operational mission, not the experimental missions of Bhaskara and Aryabhatta, India spent 1,008 crores. And at NRSC and SAC, the data reception and application, it spent 554. This is at current prices, the money spent over 25 years, right? Then the direct returns of data sales were within India 160 crore, and Antriksh made sale outside India of the data of about another 60. So sorry, it should read 220, not 120. The opportunity cost, which doesn't really come, that if we would have purchased that much amount of foreign data, the opportunity cost was 500 crore. Saving value addition is around 1,000 crore. And because India migrated from ground survey to remote sensing, they estimated through some sample surveys that this saving itself is of the order of 1,100 crores. And the economic impacts, if they were to say, one was this wasteland mapping, entire country, which has reduced from nearly 70 million to around 62 million hectare. Also, there were 3 World Bank aided projects, which is called Uttar Pradesh State Sodic Land Reclamation Project, which were all done with satellite remote sensing. So what they did was, they surveyed some 900 farmers and found what exactly is the increase in the productivity. So if you take the wasteland converted, brought back to agriculture, increase in the productivity over a longer time horizon of about 10 years, then it would come to around 2,500 crores. The Integrated Mission for Sustainable Development, IMSD, which was in 246 districts for soil conservation, roughly the number is about half to up to the same level. The potential fishing zone, what we also heard in the morning, it is estimated around 1,500, 1,600 crore. Also what was proven was actually for about 200 forest division, they tried to map or prepare a forest working plan with satellite remote sensing. Earlier it used to be purely ground survey. So they said that this has a saving and time and the implementation which they equated around 1,100 crore. And Rajiv Gandhi National Drinking Water Mission, which was to detect where to drill for groundwater, where the success rate increased from between 40 to 65 to between 80 to 85. So this enhancement of success rate is assumed that it will have an impact of 5 to 800 crore. So thus you can see the direct cost is only 220. Those of you who are interested in looking at how the government looked at the record, I was also director of National Remote Sensing. The CAG has a report in 2012, which is available, which said that the actual internal rate of return of data sale was only 6%. In fact, they added the engineering part, here only the experimental part. That's why here it is coming around 220 for the out of 1,500 crores, right? So this roughly is the status. But what is clearly understood is that this doesn't really tell the whole story. While we should talk of the GDP and economy, there are other advantages. We have not yet looked at the induced economic effect and many other things, right? So maybe later on we can improve. So let me look how others have looked at. If you look at the geospatial, so geospatial is 4 technologies: ground survey, aerial photograph, GPS and satellite, right? So the latest estimate of the market economy of geospatial in India is that it was 14,000 crore in 2021 and is likely to be 23,000 crore. But India is a net exporter of services. So the geospatial economy of India was around 38 or 39,000 in 21 and is likely to be about 52,000, and it also employs above 470,000 people. Many people include the induced effect of such a large employment and their earning and expenditure also. So this is one such issue. How much of the geospatial should really be ascribed to Earth observation or satellite is a big question. We have not included because we didn't have that estimate. Second is a very interesting thing. The National Council of Applied Economic Research, in 2020, it did a study. It looked at 2 major missions, which is called National Monsoon Mission and High Power Computing. Under National Monsoon Mission, almost 500 crores was spent competitively globally. So it was the first time government was giving money for research globally, competitive research, to improve the predictability of monsoon beyond 5 days, right? And then the HPC, they increased the processing power from 1 petaflop to 11 petaflop. So by spending 1,000 crore, they then did almost 12,000 farmers, fishermen and livestock were viewed, and they estimate that this would actually generate additional income of 50,000 crore. I find 2 issues with this work. One, you have research and you have computing facility, and you are computing the increase in the earning of the beneficiary, but the earning is based on a forecast. Forecast is made by an operational agency. Agency is National Center for Medium Range Weather Forecasting and India Meteorology Department. So they have large personnel, large facility, large observation, and no global forecasting can be done without use of satellite data, right? So the first input of global weather forecasting is the global SST, wind field, cloud, soil moisture, you name it. It's purely weather and satellite driven, right? So this is one issue. The second one which I would like to point out is what happened. The European Commission runs a very important project, Copernicus. Here it's a very important in the sense that they are committed to free, open, public data. Data has no cost. They are committing up to 2030, and for each of the 5 and 6 satellites, there is a satellite A and B. It means they will replace the satellite also. So once they did that, so one of the study which is done, I think this is done by PwC, they looked at only 10 application area. So they found that the European Commission will spend around 8.2 billion euros over this entire horizon of 2008 to 20 in building this Copernicus satellite and maintaining them and putting the data in a data hub. And when they studied 10 value chains, agriculture, forestry, urban, coast, marine, oil and gas, energy, air quality, insurance, disaster, right, and security, they found that between 2018 to 20, the economic benefits are between 16 to 21 billion, just in 3 years, while this will run for another 10 years, right, once the satellite is there. And they say they have used a conservative approach in extrapolating downstream, right? I have written in 3 boxes the environment impact, the social impact, and the economic impact factor, which were not considered in the 16.2 to 21 billion. Let us look at a conference which was, it had many things. It was done at JRC. It had many NASA, IEEE, and many things. And look at all the papers. So the conference editors, they summarized what were the methodologies adopted for computing the Earth observation benefit. There has been, if I read through it, everything I think economics would be there, from price cost, cost-based derivation to belief networks to cost effectiveness, econometric simulation, you name it, surveys, risk analysis, portfolio model, various papers have used. So still we are not sure how to really go about that. So I would like to end by just a very recent paper which has come in May, written by Sawyer. It says the 6 dimensions of value associated in the use of Copernicus Sentinel data. So we are now talking of the impact, not really the economic. So economic is there. The other dimensions are environmental, regulatory, innovation, entrepreneurship, science and technology, and societal. And we all know the use of the satellite data in disaster relief and disaster preparedness. I would like to end here saying that we need to really still work hard and define an approach for looking at the space technology and the economy tangle. Thank you very much.
Thank you so much, Professor Vinay. Okay, so decoding the space economy is not an easy task. We have 4 experts, and the numbers vary. The inputs vary and the outputs vary. So I guess the top level question is, from each of you, how do we decode the space economy? What should be included? What should be excluded? I think before we started the panel, we had a debate going already. Sreeram told us, if you look at the space economy, there's so many impacts going down. You can go from very high level moon missions, very clear, that's space economy. But it impacts, powdered milk. So do you count that as part of the space economy? Maybe yes, maybe no. So Sreeram, what should be included, what should be excluded?
Sure, thank you, Jose, and thanks, professors, for your well elucidated comments on what should be in and what should be out. As a consultant, my job is to put the cat among the pigeons, if I may, and ask questions. So some points to consider. While a lot of discourses happen on the direct impact on space economy, there is also a bunch of impacts which are indirect, or impacts which could be ascribable to advancements made because of the advancements in space technology. For example, I read somewhere that baby formula had its inputs from NASA programs on how to keep the astronauts well fed. Memory foam mattresses, again, was thanks to some of the advancements in space technology. So much so that artificial limbs and athletic shoes and the foams, a lot of these have come because of innovations that have happened in space technology. So do we look at indirect impact of some of the space technology advancements while quantifying space economy? That is question number one, and I would rather argue that you should have both a direct and an indirect impact ascribed to it. So while numbers vary anywhere between 6 billion and 10 billion, and we also saw Professor talking about a multiple of 0.028 US versus India, that's 35x. Now again, if I look at it, and it is predominantly private sector. And if I look at it, currently there are 5,000 plus private sector, space sector companies in the US, and as per a latest study done by us, it's around 500 plus in India. So the multiple there here is 10x. The economic multiple size there is 35x. So perhaps there is difference in the way the whole methodology has been looked at. So direct versus indirect again. Again, I think Professor Dadhwal did talk about should you everything about what you call geostationary, what you call geospatial should be ascribed to space. Again, there was another study which said, let me look at my numbers. Yeah, GPS is $300 billion in the US alone. Rideshare in the US is around 60 billion. Now in India in the last 2 years, right from Uber to Ola to Mine to Dunzo to Blinkit to you name it, because of that information that is beamed from the sky and because of our ability to make meaningful decisions on the ground, the indirect benefits, in my opinion, also have to find a strong a role in the economy calculation. The last point I would like to say is, while we do all of this, everything is being now looked at from a positive side, meaning what are the positive impact? Like there is a lift in space-time, there is also a drag to everything that the space sector innovations are leading into. So somewhere we have to quantify the carbon impact, the ESG impact because of space missions. The debris that's there, the impact because of that. And most importantly, somebody said, when we discovered TNT or some of those, nuclear, the negative impacts of nuclear bomb was never measured. So here the negative impacts of space technology in defense and military, that also has to be quantified in my opinion. So look at lift, drag, come up with a balance sheet, direct, indirect, come up with a net denominator number. That perhaps would give us a very clear insight into what the space economy would mean for India in this current decade and beyond. Thank you.
Great. Follow-up. If we use that methodology, I think it was mentioned earlier that Deloitte put up a number for the space economy. Was it 7 billion? Oh, yeah. But you have your own numbers, right? We haven't put numbers yet. You haven't put numbers. Okay. So I think we're all in the same range, right? So if we agree that it's between 7 to 9 billion, PwC number is 7 billion. So and I don't think we're far off, but if we use your methodology, the indirect benefits, what would be the size of the Indian space economy, in your view?
Okay, that's a lot of crystal ball gazing. So I would see. Let's look at some numbers, right? As I said, ride share in India, in US itself was close to 60 billion. And now assume India with the population and everything is, say, even take 1/10 of it. That itself would add to a 6 billion or a 5 to 6 billion. That's just one part of it. So my view would be many multiples of indirect benefits, but perhaps that has to be further quantified. And I haven't seen any study that points to the direction. Maybe it's time that SIA and others embark upon such a study. It
is going to be a huge endeavor. So, for instance, if you look at solar panels, right? started by our industry. And it was way back in the 1950s. The company that invented it went bankrupt, actually, in the US, and NASA gave them a contract, and 40, 50 years later, we have the benefits of that. So, yeah, it's going to be difficult. I like your methodology, but it's going to be quite
And I
difficult.
also, point to Professor Dadhwal, where he talked about data was what, 120 or some number he gave, because that was 7-10 years ago. Now with advanced data processing tools and AI and ML and all technologies coming up, the value of the data that is, that we have from space could be multiples of what was probably 5 to 10 years ago. That's another way of looking at how to come up with the numbers, etc. But as you said, it's a Herculean task. Direct economic benefits is probably, I wouldn't use the word straightforward, because people have, the amount of research that I've seen Professor Sunil presenting, that itself has taken so much of time and effort. Indirect would at least again take much more time and effort to even quantify. But at least it's important for us to recognize that the indirect benefits of space is equally important. One, from a numbers perspective, and two, to ignite young minds into STEM.
Great. All right. Saurabh, what should we count? What should we not count?
Well, firstly, thank you to the organizers for giving me this opportunity. So when we talk about space economy, I think what all of us would agree is that there is no standard international definition for the space economy. But how we view that is that space economy will encompass the core space activities and then space-enabled activities. Now, when we're talking about core space activities, this would largely have areas like access to space. Access to space would include satellite manufacturing, launch vehicle manufacturing. We'll also have the downstream part of the industry, which has Earth observation, satellite communication, navigation, so on and so forth. We'll also have the space situational awareness, which is again a big area, especially for the defense sector as a whole. Then we have the in-orbit space economy, which in previous sessions, as well as this one, people have spoken about space debris and the interspace economy, which is there. So there is a core space activity, which firstly has to be considered, and there has to be an economic element to it. Now, moving on, there is a space-enabled economy, which Sreeram and also all the other panelists also spoke, that now this could also include ride sharing as an example. This would also have delivery or logistics as an example. This would also have even the legal industry as an example, because a lot of multilateral agreements have to be framed. So space-enabled economy would also kind of have a lot of economic value, which is given to these ancillary industries. And then if you're talking about the non-economic impacts, which Professor Sunil also mentioned, that there are a lot of environmental impact. They might not be very easy to quantify, but then they're extremely important. And they also form a part of the larger space economy. So if we were to look at the space economy, we would kind of look at in that fashion. There's a core space activity, and then there's a ancillary or space-enabled economy.
Okay, agreed. So the first part, the core, it's kind of easier, quote unquote, to do, right? Yeah. It's the rest. It's difficult. Professor Sunil, you mentioned in your presentation, and I hope I didn't mishear you. You mentioned that as a percentage of GDP, this will decline for India unless the government steps in and makes that investment. Is that correct?
Yeah.
Okay. Before we go to your answer, or a follow-up question, does the audience agree that without Israel, Indian government really putting the effort to invest in the space industry, as a percentage of GDP for India, it's going to decrease? Show of hands. It's going to be government-led, Israel-led. Count about 6. Assuming the rest don't agree, it's going to continue to grow without Israel and government involvement?
I think it's somewhere in between. I think the high capital intensive projects, like if it's a small satellite launch vehicle, I think the private industry is quite capable of getting there. They have the innovative mindset, there is passion, there is also demand. But in, say, a GSLV launch or a PSLV launch, in the upstream, which requires manufacturing of high-end, and operations which again require high-end operation of satellite, and in the downstream, which again the delivery services which require high-end. That's where the government has to step in. Okay. And I think it's a mixed, so there's no black and white answer. That's what I
Okay. So what should we be counting in order? And please shed some light on the percentage of GDP.
First of all, I think you have to make a very clear distinction between the size and the impact. Whenever we are discussing, we seem to mixing up the two, which is of course understandable, because sometimes it's difficult to differentiate between the size and impact. Now let me make it very clear. Take for instance the defense industry, okay? Will you include, for instance, internet and microwave oven as part of the defense economy? Because they were based, we know from our understanding that these technologies were developed by the defense industry in the US, okay? So if you are going to include all kinds of downstream industries as part of the an economy, then the economy will be too large and not very meaningful to understand, because the contours become so vast and ill-defined that any kind of policy impact would be very difficult to talk about. That's number one. Now, one thing which I could, because of lack of time and I could not go into detail, was the structure of India's space economy. And using the UK space model, we divide that into 4, but we did not have the most important segment, as according to us, is space applications, which is a particular industry which is exclusively dependent on space technology, and that I would call it the direct-to-home satellites, DTH. So if you look at any country for that matter, the UK or the US, the most important component of the space economy is the DTH sector, which is entirely based on space technology. Okay. Now, ride sharing, you said, is based on space technology, but is GPS an Indian space technology? And so if Uber and Ola are using GPS, would you then include that as part of India's space economy? This is the point that one has to look into, because as a national account statistician, we would only we are talking about the domestic product, value of goods and services which are produced within a country during a specified period of time, okay? We will not include things which are bought from outside, because those have to be netted out, okay. Yeah.
So sat-nav shouldn't be included.
Which one?
Satellite navigation shouldn't be included. I mean,
well, if it is based on Indian technology, it should be included. If it is not based on Indian technology, it should not be included.
There was a stat this morning.
But we can call that as a larger impact of the space economy, but not as part of the size of India's space economy.
This morning's session, there was a statistic. 380 billion is the size of the space economy. 51% is satellite navigation. Is that the right component to put there? Because if you take that out, you have the industry value.
Yeah, but as far as I understand, the most important component of the space economy is space applications, of which satellite navigation is one of them, okay? And because the telecom part of it comes from the location services, right, which is part of the satellite navigation, but DTH is the single largest part.
Sorry, follow up. Satellite radio, should that be in?
Yes.
Okay. Yes. Do you have a question, sir?
Yes, please. And, so my name is Paul Fevre. I'm from the Satellite Applications Catapult in the UK. So, of course, we've been involved with the methodologies and really appreciate the way that you're actually applying this intelligently to the Indian challenge. I think that I'd like to touch on 2 points. One, the aspect of the boundary condition. I think you can define a services boundary and understand that that is something that can be quantified and could be direct. Even for navigation, there are navigation services that are not free, and those should be included clearly from a services boundary, but then you've got the impact. I actually think undertaking an impact assessment is critical for the sector. We need to be able to demonstrate that we're having an impact, an economic impact. It's something that Professor also, because I can't read your name, my glasses are in my pocket. You're talking about the other impacts. I think we need to actually put significant effort into understanding the environmental impact. Because in a world where we're trying to achieve net zero carbon, satellites have a significant contribution, not in terms of having a carbon footprint themselves, but in terms of offsetting by allowing for essentially better use of human resources on a global scale. And if I could just touch on one last thing with regard to your question about ISRO and government incentivization. What we're seeing in the UK is that it isn't actually about funding the development of the space technology. It's about government as an intelligent customer. It's about identifying that governments can use services for the benefit of the citizens and committing to buying services. And that creates essentially the drive for investment. It creates new demand.
Thank you. Great insights. Any final thoughts, Professor Vinay? What should be in? What should be out? Is impact more important? Is value more important?
Yeah, I would like to maybe throw up some more dust on whatever confusion we have. I very much support what we did, because everybody tries to make an estimate from the point of his view or the direction from which he comes. We were looking at conservative estimate. So obviously the conservative estimates would be lower. Second, there were some things which data was not available. So instead of trying to guess, we dropped that account and it is listed what exactly we missed. And third important point is, when we say let us say satellite drives a technology, in the sense, one very simple example, what we discussed was, in India, all the ATMs work on VPN, right? So VPN is a satellite technology. There could be 2 lakh, 3 lakh VPN. The actual cost of the VPN and its maintenance is what is the ground service. But you can't start taking the banking transaction number and say that is the space economy. So we very clearly wanted to, in the entire economy, what exactly is the space contribution. And as you also clearly picked up, the geospatial, which in India is very big, and Hyderabad and Bangalore both are very big geospatial. It is aircraft, drone, ground survey, mapping, services, but how much is high resolution space, that data sale when it is available, and its interpretation cost. Those two only we would like to add. Until those numbers we can't resolve, we wouldn't like to really add the inflated number. So this is the point from where we come from. Right. But impact, as was pointed out, yes, impact should be separately kept. And not only that, our goal where we want to reach, whether it is SDG or anything, they cannot be really reached till we ensure that we have satellite-based monitoring. So we should not try to use the space and its economic to justify space. In my belief, it is overly justified and there cannot be any question. We were trying to answer its direct contribution to the GDP.
Point well taken. So I think we have consensus that the value is useful, but the impact is more important. Is that correct? Yes? Audience agree as well? Now, having said that, so value is important, but impact is even more important. So when we measure the Indian space economy, what should be targeted, right? So if we go to the core, manufacturing, launch, services, even lunar markets, etc. These are the value. The impact, as the NASA solar arrays, it's 50 years. It's really long term. So I'll just go down the line. What should India target so that you get the best impact for your country? Manufacturing, launch, satellite building, etc.
So I'll try to address that in a slightly different manner. We did a study of more than 500 private sector, space sector players in country. And we found majority of them sitting in downstream data applications. And the ones which are sitting in upstream and midstream are the traditional ISRO vendors. And the downstream people have started coming into picture in the last 3 to 5 years. Right? And because of the data availability and the tools availability and the digital literacy and everything going, the uptake is increasing. Now, another way of looking at it, if you look at innovations that is happening in space and space technology in India compared to US, for example, like we have compared, it might perhaps be worthwhile to look at the research that is happening in latest space technology in India versus the US or the European universities. Based on initial assessment, our understanding is that we are a bit behind in terms of basic research in upstream and midstream, at least in the Indian academic system compared to the global system. Now, it's very, I wouldn't use the word easy, it is very, the entry barrier is low for people who are wanting to innovate in the downstream data, downstream part of the space economy, but it's quite hard and capital intensive and technology intensive, requiring a huge institutional support for people wanting to innovate in the upstream and then the midstream. Again, coming back to your question is, you said, should ISRO, without ISRO, would this exist? So I would rather flip saying that it's not with ISRO or without ISRO. It's like ISRO being a catalyst for such innovations and technology in the midstream and upstream is what will really drive one innovation within the private sector, with grants, with challenges, and also in the academy with specific chairs and investments thrown in. That is what my view would be to say that this is what is needed to really catalyze India's private sector, space sector foray outside a downstream, which has been sufficiently catalyzed in my opinion.
Okay, so if I hear you correctly, ISRO is like the rock you throw in the pond, and then the ripple effects go to academia and private sector. Agree?
Yeah, so I think I'll take a slightly different view here. And I'm keeping in context the current reforms and announcements which have happened. So, so if we look at the space industry worldwide, and not just India, obviously US will have a different model and Europe has a different model. But across, the common denominator is that space as an industry largely requires an anchor customer. Now that anchor customer are sometimes, or in fact most of the times, are institutions, and these are institutions like ISRO. And also defense is also another major customer if we look at the anchor customers, that bases which the space economy largely thrives and survives. So if we were to talk about India and if we were to value India's space economy, I think and if we see ISRO as an anchor customer, initially obviously as a hand-holding or a partnering support, giving partnering support to the industry, and then utilizing those capabilities which have been built up as the end customer, I think that is one part. Secondly, defense has to be entrenched into this sector so that the sector has another customer base. And also, if we talk about, we spoke about upstream and downstream. So what is also essential is that there is a larger support which is given on the upstream side. The reason for that is because it is highly capital intensive, it is highly risky. Downstream is there because there is upstream. There's a precondition for downstream because there are satellites in the orbit. So I think, and because this is a highly capital intensive area within the space economy, I think a special focus also has to be given on the upstream part of the industry.
Okay, so interesting ideas. So anchor client, if you look at SpaceX, right? They were successful because of US government contracts. So I agree with you. I think the panel agrees as well. Israel has to be more involved. Problem is budget though, right? 1.7 billion, and if you look at the US budget, it's way, way higher than that. If you look at China's budget, same thing. So is the secret to success is funding ISRO a lot more, and if it's so, how much?
Yeah, so I'll possibly take three different economies here. So if you're talking about US economy, it is largely self-sustaining. The budgets are huge, and the amount of investment that goes into the space economy is also consumed within. However, if we come slightly eastwards from the US, European space economy follows a model of customers outside of the European region as well. And this is, I think, where India can also potentially look. Relying completely on ISRO is not, I would say, prescriptive, because obviously there are budget constraints, there are, among many other constraints. So I think there has to be a right balance where ISRO plus defense is an anchor customer, but India also has to look outwards for exports, where we have to find newer customers, possibly maybe in the US or in other more developed areas where the funding and the revenue support is huge.
What comes first, ISRO added funding or going out, or both at the same
I
time?
think both together at the same time will ensure that the sector stays afloat and also thrives in the future.
Professor Sunil, do you agree with that?
My take on this is slightly different, because I just respond to the gentleman's point which was made earlier, that unless the government is a major customer, and we tend to use the term public technology procurement as a way of promoting innovations especially in high technologies. So unless the budget for ISRO is systematically maintained, we cannot have any kind of ripple effects, as you put it, to happen. And the withdrawal of ISRO or government as a public technology procurement agency should be gradually reduced over a period of time, so that the share vacated by government can be taken up by the private sector. Our private sector has not reached the same level. Let me give you an example. We are all now sitting here, because I'm wearing a mask, of course, but nevertheless, we are all sitting here for an in-person meeting because we have all been vaccinated, and vaccines have come up in such a very short period of time, of about 9 months after the genomic sequence for SARS-CoV-2 was announced. How did that happen? Essentially because the US companies were able to develop very highly effective vaccines within a very short period of time. And how did they do that? Did they do that on their own, or did they get federal support in various ways? And we know from whatever is written, there is the Operation Warp Speed. For instance, $26 billion were made available to these companies. And also, there was a fair amount of investments in basic research. US never neglected basic research in medicines. So likewise, I think in any area of high technology, government has to be there as a major catalyst. And if government is going to withdraw, and the size of the space economy, and of course, its impacts also will be adversely affected.
Okay. Professor Vinay, final word on ISRO and government funding. How do we get to the growth that India is
Yeah,
looking to the
so
future?
one basically is what we indicate in that paper is there has been a slight decrease in the ISRO budget as a function of the GDP. So because when you start talking of one sector alone, you forget the government have to holistically allocate budget for education, infrastructure, defense, or whatever their priorities are. But still, let us say by point, I think it has by 0.003 or something, it has fallen down in 4 years. Now, on their side, I can say the GDP was growing much faster. So this budget was not growing at the same rate. But the point which is simultaneously made, the very large space economy, they are giving, like if you take Earth observation and the two biggest high resolution satellite company, Maxar, etc., they have 7-8 year running contract of $50 million or etc. of satellite data per year. So they can really invest in a high technology satellite. They know data will sell. And they make money by selling that data to outsiders. So this captive market, I think, is important. So while the decrease could be due to various factors, but the sustained money and incentive to be made available for space economy to grow is very, very critical. That is what.
Great. All right. I think we're in agreement. Government, level playing field, open the floodgates of India, and everybody competes, everybody innovates. Government support, ISRO maybe an anchor client, an anchor sort of that stone that produces the impulse. Okay, great. So we're still not sure how to decode the economy, but at least we know what needs to be done. Okay, having said that, let's talk about Elon Musk, Starlink, and SpaceX. They are changing the landscape, for good or bad. They don't need public funding because Elon Musk is the richest man in the world, and if Starlink doesn't make money, that's fine. And then you have Jeff Bezos coming in with Kuiper. He has launched contracts. So again, the traditional economics, the way of doing business might not be there. So when we talk about decoding the economy, right? Elon Musk has Starlink, SpaceX, Tesla. He's probably going to put connections in the car. He has solar cities, so he has the power and the batteries, so the entire ecosystem is in place. Bezos has Amazon. Amazon Prime, customers can be leveraged. AWS, cloud can be leveraged. So in light of just these two people who are changing the industry, how does India compete and do the numbers in this emerging landscape going forward? Please.
I never expected this question. It's very, very, very loaded and pertinent, but let me put it differently. I'll draw a parallel from another industry. When Government of India started opening up drones as a sector, initial days, number of players were small startups and others who were coming into picture, right? Then with industry consultations and everything, the speed at which the policy reforms took a lot of people by surprise. The rules were liberalized, no-fly zones or fly zones were easily identified, beyond visual line of sight, maneuvering, etc. was made much more easier. The voice of the industry was heard. So what happened after that, when the voice of the industry started getting heard, the biggies, I wouldn't name them, have started coming into the drones industry as a key large player. The biggies in India, you know who they are. So currently, the way I am seeing it is after the launch of ISPA by the Honorary Prime Minister a year and a month ago, traction has started in India. The policies are getting liberalized. The rules are modified. Some kind of level playing field is slowly emerging. It's not going to be a monopoly of ISRO any longer. Like Mr. Somnath himself comes and says in public conferences that his prime job is to make private sector succeed. It's a matter of time before the equivalent of the Bezos or the Musks in India, or among the top 10 richest people in the world, enter this particular sector. That tipping point, I would believe, is 6 to 18 months away. And once that happens, we would see this private sector in space sector a very, very different space. We celebrated $51 million funding that a startup in India got. We celebrated that, but we would see at least 50, 100x multiples of investments of that kind coming in from the biggies. Is my hope, belief, I wouldn't call it a prediction. From a similar industry perspective, what we've seen in terms of economy opening up, I really hope and believe that will happen. And if that happens, it's for the betterment of the society, for better impact of space technology to the common citizen.
Great. So that's not bad. 6 to 18 months, and you unleash the Bezos and the Musks of India. Do you agree, Professor?
Yeah, so I have no comment on 6 to 18 month, but I would tend to agree in the sense that we were very poor users of data till a company came and gave data almost free. And then we started being the largest consumer of the data. So it can happen. So let us hope that what he says is okay. But 6 to 18, I have just no view because I don't have that type of exposure to the industry.
Okay, well put. I hope you're right. So I guess giving it for free, to me it sounds like drop the price, almost for free, and then you get the market started. Your view, please. How do you compete with Musk and Bezos?
Yeah, so I look at it slightly differently. So if I'm looking at the complete space value chain, I see that there are multiple entry points where possibly SpaceX or Blue Origin are operating. That is largely on the upstream side, which is highly capital intensive. However, if we are looking at India as a nation, there are multiple entry points where we can maybe right now focus, given the existing capabilities that we have. So India is extremely high on IT and software and analytics. These are some really, we have demonstrated capabilities in these areas. So I would think that because that is a good starting point, maybe downstream area with the advanced technologies where we can utilize the spatial imagery to provide insights for the end customer could be one good entry point. And then once we have got our reasonable valuations, we have proven business models, then we can possibly move up the value chain. So I see it very, very differently from given the existing advantages we have.
That's an interesting point. So in terms of get the billionaires of India to, you get the entrepreneurs and then you go up. Yeah. Okay, interesting point. Sir, and I was told we have 5 minutes.
I'm not sure whether, posing the question this way, that, we should have a SpaceX. The same question was asked in the case of IT services. We should have a Google and Facebook, etc., and so on, but we never had, okay? Although the computer services industry in India is a world leader since 2005 and has been maintaining that, but we never had a company such as, the ones that you mentioned, okay? But I think major India's comparative advantage is in cost. So as I mentioned earlier, it's a frugal innovator. So with limited resources, it's able to provide the same service at much cheaper cost, okay? So I think that many frugal innovators may come up here. So that's, and so we can provide that service, space service, at a much cheaper cost than other people. So I think that should be the way to look at it, rather than thinking in terms of SpaceX and other big companies, because I'm not too sure whether having such big companies, big monopolies is a great thing.
Great, all right. We don't have consensus. We can't decode the space economy. We can't, we don't know what the way forward. There are many things, but it just shows that it's such a dynamic market. So last survey from me, and I think we have an audience question. How does India compete, not just with Musk and Bezos, but in the world stage? Do we go, Israel should spend? Do we unleash billionaires? Or do we go bottom up with the entrepreneurs in Bangalore, Delhi, everywhere? So bottom up. 5, 6. Israel as the engine of growth. 1, 2, 3, 4, 5, kind of equal. And release the billionaires of India. 3. So tied on the first. Combination of all. That should be a working formula, right? It's going to be messy, but hopefully it works. We have an audience question, please. And please identify your name. And the gentleman in front, your previous question, did get a chance to ask your name, but please provide it later.
Hi, my name is Harini. I'm a PhD scholar. I'm working on outer space. I was just thinking about the same question that you asked about having the next SpaceX or Blue Origin. But in my opinion, I don't think India would ever want a personality-driven industry, but more like something that offers better services. And I think that's where I would probably agree with the 6 to 18 months input that's made on we might be able to give valuable solutions in that time frame, which is something that we can expect, but not like the next SpaceX, because that's a huge industry.
Okay. All right, sir, your name, please. We didn't get it.
I'm Vishal Sigawa at the Aerospace Independence Leader.
Great. Thank you so much for your question. I think we're out of time. Very interesting. We're just scratching the surface, I think. But very interesting times for India. Congratulations again on OneWeb. Happy Diwali. Please join me in appreciating our panelists with a big round of applause. Thank you.
Thank you very much indeed. And ladies and gentlemen, with that we close the proceedings of this session. Once again, thanking our eminent panel here for the wonderful discussions and presentations that we had from them. And on that note, we now break for tea. And the next session is a combined session where all the tracks will be combining and will be held from this stage from 4:30 p.m. onwards. So please enjoy your cup of tea and be back and seated 5 minutes before 4:30. Thank you very much indeed. And once again for the startups. Okay, tea is served inside this hall only, ladies and gentlemen, so you can enjoy your cup of tea inside this hall itself. And once again, for the representatives of startups, tomorrow we are going to have a mentorship luncheon and meeting at Inspire in the afternoon. Kindly register for that today. Thank you.